Now we are going to talk about the mechanical properties of materials. And we are going to talk about the tensile test and compressive or the compression test in general. So I'm going to give an introduction first, and then I'm going to give more details about the standardization and the types of the tests that we are commonly used for checking the mechanical properties of materials. The design of machines and structures so that they will function properly requires that we understand the mechanical behavior of the materials being used. This is something very important. In order to know how to design structures and machines, we need to know how the mechanical behavior of the materials is going to, or what is the mechanical behavior of the material is going to be. So we need to know what is the type of the steel, how it will behave, whether it is mild steel or high strength steel, for example, whether it is a concrete with high strength concrete, or it is a type of material that is ductile or brittle. We need to know the type of the material and the mechanical behavior. Okay. Commonly, the only way to determine how materials behave when they are subjected to loads is to perform experiments in the laboratory. This is most commonly used, and I think that most of you have experienced before an experiment in the laboratory that is providing the material or the mechanical behavior of the material, whether it's for steel or concrete. The usual procedure is to place small specimens of the material in testing machines, because small specimens, as you know, that we are not dealing with the whole structure or the whole element. If we're talking about member, like steel member, for example, we need only a bar that is going to be tested. If we're talking about concrete, for example, we want a cube that is going to be tested. So it is a small specimen of the material. We're going to put it in the testing machine, and then we're going to apply the loads. It's clear here. And then measure the resulting deformations, such as changes in length and changes in diameter. So we're going to check what are the changes, okay, the deformation, whether in length or in diameter. Most materials testing laboratories are equipped with machines capable of loading specimens in a variety of ways, including both static and dynamic loading in tension and compression. So we have like different types. I'm going to talk about the static and dynamic loading at the end of this video, and tension and compression also, whether it is under tension or under compression. If we are talking about steel, commonly we are testing or we are performing tensile test. For concrete, we are making or performing compressive tests. In a properly designed specimen, failure will occur in the prismatic portion of the specimen, where the stress distribution is uniform and the bar is subjected only to the pure tension. That's very true, because if we have a bar like this, for example, okay, sorry, drawing by mouse is a nightmare, but sorry, I do not have my electronic pen now. So anyway, so this is the bar, as you can see here, and we have like tensile force here. Okay, so the point is we are expecting the failure to be in the middle. Okay, we call this middle, we call it the prismatic portion. Prismatic portion means that the portion where that it has a uniform cross section. Okay, so this is the meaning of it. We are not expecting the failure to be here toward the end, here or here, for example. No, this is not expected. This is going to be rejected test, but we are expecting the failure of the specimen to be in this prismatic part or portion. Okay. Now, a typical tensile test machine a typical tensile test machine with automatic data processing system. Commonly, if you have a laboratory in your campus, you're going to find that we have a universal testing machine. Commonly, it is similar to one way or another to this shape as you can see it here. So we have like upper and lower pistons or platforms here, and we are putting the specimen here in the middle, and then this universal testing machine is connected directly to a controlling system or a data acquisition system where the strain gauges and the deformation in length and cross-section can be monitored and acquired here, and the data processing system is going to work and give us the stress strain diagram at the end. You can find many videos on YouTube regarding this typical tensile test machine. Okay. And this is for a typical compression test machine. You are going to find that we have also very similar to the previous. We are putting our cylinder here, concrete cylinder for example, and we are putting load from above, and then there is data acquisition system, and then until the failure of the specimen itself. Okay. Now let's go to the next part, which is the standardization of the tests and so on. In a properly designed specimen, failure will occur in the prismatic portion of the specimen where the stress distribution is uniform and the bar is subjected only to pure tension. I mentioned about this. Okay. The stress distribution is uniform. We are keening to the stress distribution to be uniform always. Okay, and in the prismatic bar. In order that test results will be comparable, the dimensions of test specimens and the methods of applying loads must be standardized. That's very true, because if you are in a country and you want to know whether that this concrete is going to be meeting or is meeting the specifications or not, or your steel, structure steel that you are using is meeting the specifications, we need a standardization for the whole process, the specimen dimensions, and in the same time like benchmark method for the standardization. So that's the meaning here, in order the test results will be comparable, because whenever I say to you that the concrete specimen, for example, the concrete cylinder is having strengths with 30 something, for example, then this 30 means that it is applicable everywhere. That if your specimen is providing 25, for example, this means that your specimen is weaker than mine, okay, and so on and so forth. And the dimensions as well. The dimensions of the cylinder, for example, must be with 4 inch by 8 inch or 6 inch by 12 inch, or whatever the type of the cylinder that you are using, or whether it's a beam, for example. One of the major standards organizations in the United States is the American Society for Testing and Materials, ASTM, which is a technical society that publishes specifications and standards for materials and testing. It's very famous, and you are going to find it everywhere that you go whenever that you are making testing, whether that you are inside the US or outside of it. Other standardizing organizations are the American Standards Association, ASA, and the National Institute of Standards and Technology, NIST. Similar organizations exist in other countries. So we have, or other countries have also their own standardization, but ASTM is one of the most globally or worldwide accepted organization for standardization of testing for steel and concrete and different materials. Okay. Regarding testing types, we have two different types of testing. One is static and another one is dynamic. So we call it static test and dynamic tests. In static test, the load is applied slowly. Take care of this word here, slowly. because we are not, okay, it is applied slowly, and the precise rate of loading is not of interest because it doesn't affect the behavior of the specimen. Whenever that we apply the load on the specimen, we're not expecting anything related to the load rating or the rate of loading here on the specimen itself. We're not expecting anything, so we are applying the load statically. So we need to know what is the static behavior of the material or of this element. Okay, so that's the issue here. So this is what we call it, the static test. However, in dynamic test, the load is applied rapidly. So take care of this word, rapidly. Means that there is load, or the rate of loading here, rapidly. The load is not being applied slowly. And sometimes in a cyclic manner. Sometimes common protocol for loading is something like this, which is increasing after that. Okay, that is going up and down. This is what we call it, cyclic or cyclical manner, since the nature of a dynamic load affects the properties of the materials. The rate of loading must also be measured. Okay, so this is the load, or the rate of loading must be measured and must be recorded. So anyway, these are two different types of loading, static and dynamic, and this is how the material behavior can be checked. Let's recap what I have said in this video. It is a short video, but it's important. I was talking about the mechanical properties of materials, what are the type of tests that we are using, and what are the type of standardization, and in the same time what are the type of equipments that we can use. We give an introduction about this. The most important thing is related to the laboratories that is having testing machines, whether for static or dynamic loading. And after that we mention about the types of testing machine for a typical tensile test machine, as you can see it here, and we have a typical compression test. We have shown it here. You can find a lot of videos on YouTube for this, and you can also find after that a standardization for whatever the type of testing that you are doing. We need to standardize the dimensions and the protocol of loading itself, and we said and mentioned that there is ASTM, there is ASA, and NIST. They are very famous organizations, and their testing protocols are widely accepted. And then we have two types of testing, which are static and dynamic tests. And static, remember that the load is being applied slowly and the rate of loading is not important. However, in dynamic test, the load is being applied rapidly, and the load rate, or the rate of loading, is important. Okay, thank you for this video, and see you in the next one.